So welcome to another episode of Beta Talk. This season is being sponsored by Primary Pro, which is a professional outside insulation kit for the primary pipework from heat pumps. Check them out on their website. So today I'm joined by Dan Large. He's the director at Solaris Energy. I interviewed him the other day. He's been involved with heat pumps for quite a long time now, so I wanted to get the opinion of someone that's been doing this for a while to see if anything's changed. It was a fantastic chat. Dan has been involved. One of the things I really like what their company does is they use VDI 2035 methods for water quality, and he discusses why he does that. Remembering that he's been doing heat pumps for quite a while. He's also part of the MCS installer working group, along with people like Emma from IMS and Leah from Your End Your Way, and Barry, who I have on the podcast regularly. He's also involved in that. And interestingly, he's also started to import a particular make of heat pump, Kronoterm. So we chat to him about why he's decided to do that. I don't think it was ever part of their business plan, but because he's been around lots of different types of heat pumps, he found that this particular model can suit his needs and customers' needs better, and it sort of has a bit of a controls theme. And for the regular listeners, you would have heard Ken Bone and I chat about controls not so long back. It's a great interview. He's one of the sort of installers I reckon. As you know, if you're a regular listener, you'll know I get asked from some lovely people to recommend them an engineer. So all the way up to people like Amber Rudd, who was our once upon a time energy secretary, and I've had her special advisor. I've organised his heat pump. Even an ex-Lord Mayor of the City of London has contacted me, and people from Ofgem and this kind of thing. And the managing director of the company that puts on the installer show, which is coming in June, please come there, reached out to me for a recommendation of an engineer to do the heat pump in his home, and Dan Large is the person I recommended. And while we're on the theme of the installer show, as I mentioned, it's coming up. I'm going to be doing some exciting stuff there. I've got a couple of talks I'll be doing my live audience podcast. But Installer have allowed me to do something very, very special. I think it's a world first. So if you're a manufacturer, it doesn't matter whether you manufacture heat pumps, boilers or components, do get in touch, because I can get you involved, and obviously you want to be seen as being involved. Like I say, it's quite exciting. It kind of links with something I wanted to do, I still want to do, around media, around collaboration, around getting the correct information out there. We've got a lot of information now being churned out every day, really, about heat pumps and heating and decarbonising heating, and it's being recognised by entities all the way up to the energy department that that information is quite heterogeneous. So I've got this idea that I want to do, and Chris Stark, who you all know would have been he was the CEO of the Climate Change Committee. I sort of told him a little bit about what I wanted to do just before Christmas, I think it was, and he wrote me a lovely little piece, a little testimonial that I can use. I'll read it out. Nathan is one of the UK's clean heat leaders, so I always watch him closely. This collaborative media venture is an exciting next step. We need positive voices like Nathan's to help broaden knowledge around retrofit and heat pump installations. So I'm doing something very exciting at the Installer Show. If you are a manufacturer, reach out to me in an email if you got it, or you can reach out to me direct message on LinkedIn, and obviously you will want to be involved. So on with the show. So welcome to the show, Dan. It's good to meet you. It's a lovely sunny day where I am, and we've already established it's lovely and sunny where you are. So tell us a little bit about your company, Solaris Energy, and your journey into sort of the renewable world, but your journey before that. How did you get into heating?
Yeah. Okay. Well, I mean, I was about 19. I kind of left school and was working, I don't know, several jobs. I ended up on a building site, and just as a labourer. And it was actually my mum that kind of said, Dan, you need to go out and get a proper job, and thought, well, there's a plumber down the road. I'll try, I'll speak to him, and kind of pushed me in that direction. I thought, well, it's better than not doing anything. And I quite liked. I saw, I know, on the site I was working on at the time, I saw a plumber working there, and I thought that looks quite interesting. But anyway, yeah, did a plumbing and heating apprenticeship with just like a one-man band. Well, it was actually him and his son. He was kind of old school, did everything in a certain way, packed his van in a certain way, which was great. So I learned some good skills from them initially, but I found I got more and more interest into the heating side of plumbing, and so heating and gas boilers and so on. So after a couple of years, I did my apprenticeship and decided I needed to move on to progress. So I did my gas and just pay for that myself, and then and went and worked for well, a couple of jobs. I worked up in London for a little while, and then got a job at a plumbing heating firm down in Kent, just doing, and I was working with the boiler breakdown. So I was doing a lot of servicing work and breakdowns on boilers, and from there, kind of progressed, worked into a manufacturer. So I worked for a heat team, the service department for Baxi and Potterton and so on boilers, which was great because I started getting more into the depth of heating controls, and they had some good training there. But again, after a few years there, I found myself kind of you get your job list for the next day, and you have 8 jobs, and you go, well, that's a fan, that's a gas valve, that, and it was kind of became a bit monotonous. And I knew a guy who had a plumbing and heating firm at the time, and I was playing squash. Saw him down the squash club, and he said, "Oh, he was looking for a technical manager." I said, "Oh, well, that's really interesting." Didn't really think of much at the time. Then about a week later, I was just driving along and thought, I was just doing the same thing again on my own, going out servicing boilers, doing 8 jobs a day, 8 jobs a day. So I rang him up and said, "Are you still looking for someone?" He said, "No, yeah, come in for an interview." And when interviewed, gave us the job. And one of the main things is we're looking to go into heat pumps. So that was, what was that now, 15, 16 years ago. Right. So they were just, as a company, they were established plumbing and heating firm doing site work, 100 units, and then doing renovation work and stuff. And they wanted to start doing heat pumps. And because my skill set was good with kind of breakdown and controls and fixing things, it was, I found it really interesting. So that started that progress where we started fitting heat pumps. I started going out, and there happened to be a company at the time installing a lot of Danfoss heat pumps. And he was doing it. He was a good salesman because he sold quite a few, but he didn't know what he was doing. So we kept going behind him and getting calls, and these heat pumps not working. So I had to go out and fix them, and it was the best learning curve to go out and see all the things you shouldn't be doing straight away. And that helped kind of progress my kind of whole role into sort of the design element and hydraulic systems and because I think when you go from kind of the plumbing heating world with boilers, it's so aimed at just purely the gas line, gas safety, and especially domestically, you don't go into depths of, you will do in your level 3, but it's not really like the actual hydraulic design and setting up system, commissioning, while you're doing everything. As soon as you go into a heat pump, all these things, you just cannot ignore any of them. Yeah. So it was great. We're doing that. We're starting to install more heat pumps. We installed heat pumps from Mitsubishi, or I think I remember even seeing a Heat King at one point. Dakin units and so on. It was great. And then we started fitting Danfoss, Nebe, Steel Weltron, air source, ground source systems, doing a lot more design. I got then involved with MCS a bit at the time then as well, with their working groups. And so really started coming entrenched in the business. And I was really kind of focused on how do I get as much information out as possible to design these systems properly. And that was the hardest part at the time. Because 15 years ago, there was no real manual. There's no one really helping out. You would speak to manufacturers, but they would have some inklings on how their product worked. But it was
less of the system.
Yeah, exactly. And then I think what helped out the most at the time was you'd go on a few sort of a manufacturer, jollies as such, factory tours, whatever. But actually, those were probably the most helpful because you would meet like-minded installers. and you would start talking shop, and you start, oh, I'm using this valve. Oh, yeah, have you been using this? This is much better. Or uh, starting to change in terms of product knowledge. And that was the real skill at the time, was actually finding out what products are out there and what you can do, and start kind of collating all this information, because the industry was still, Go Geothermal at the time were good. They were kind of one of the companies who were starting to get products. So it was easier to find solutions for the problems you had installing heat pumps. Anyway, I stayed there for about 6 years, became technical director, and but decided to, so it would have been 8 years ago now, set up my own company, so Solaris Energy.
Yep.
And I wanted to focus purely on heat pumps, and I wanted to, it was more kind of, I was thinking I'd be a bit of consultancy, a bit of installation, more, more bespoke systems. Didn't really know 100% what's going to happen, but my main focus was, I'm only going to do heat pumps. We're gonna design ground, air, water, whatever source heat pumps you want, domestic or commercial. We'll install, we'll do prefabrication, and then we'll do an aftercare. So I will maintain and look after heat pumps. Yeah, so that was 8 years ago, and then suddenly, like anything in business, things happened, and you just follow whatever trends sort of happen. Managed to get some traction, doing some decent enough installs, getting a range of different ground and air from just contacts I already had. And then the business sort of slowly grew. I think COVID gave it a bit of a change the dynamic slightly, because sort of the work I was doing at the time were kind of prefabrication, larger sort of, because of the RHI at the time. You had a lot of sort of more stately homes or big houses having heat pump systems, and so I was doing quite a bit of them prefabrication, where we, at the time, we then had moved into a warehouse and we were prefabricating systems. So not doing lots of volumes, but doing more interesting jobs. But that sort of quietened down, and RHI came to an end, and then RHI came to an end, and then we had COVID, and COVID, then we started doing more domestic installs. We did some stuff with Octopus at the time. They were just coming into installing the heat pumps, and they wanted to understand how it worked. They wanted the processes and stuff. So we did about 12 installs for them, and I'm pretty sure they ignored everything we said. But hey, that was it. It was all too expensive, because we were using press systems. So we use Vega press systems.
I've been out to that.
Yeah, we love it. It's just because it just got a really good range of product. So we use Vega, so they didn't want to use press, obviously. We were working with LS8 at the time. It's now IWTM. On the PDI 2035, everyone's using for that, following that standard. So for chemical-free water treatment, obviously that comes with a cost, and just stuff from the valves we're using, and making sure, expansion vessels, putting service valves in, so you can maintain them. And there's probably little bits they took from it, and we do a lot of drawing as well, so a lot of CAD work. So I found, like, in the industry, people respond better with doing drawings rather than writing. So, and I'm not the best writer, so I'm very much a visual person. I like getting everything onto a drawing, put as many notes as possible. Generally, an installer is going to follow that, or one of our guys will, and then other trades can understand it as well. So we kind of done all that, and fine. They took what they wanted out of it, and they've gone and done their own thing, and obviously they're very successful at doing it, and they've got enough capital to do what they like, really. So then we moved on, and then from that we kind of managed to build up a little bit of an installation team. So suddenly then I had a couple of install teams permanently employed, operations manager, I had an admin staff. We then had a bookkeeper, a friend, one of my school friends and close friends then joined as a business director. So he came in to help with the running of the business, so I could kind of carry on doing the technical side and grow that. And then we started progressing, doing a little bit more. So we do probably domestically 70 heat pump installs a year, 70 air source, something like
that. Yeah.
And then probably maybe a handful of ground. Found it tapered off, but actually we've got some reason at the moment, we've got some influx of ground source systems in London for whatever reason. I don't know why. think a few of the reasons are they can't get planning for external air source units, noise restraints, conditions and stuff. But anyway, so we've regressed that, and then also 2 years ago, or just over 2 years ago, got a little bit frustrated with manufacturers. I sometimes find it quite difficult when you're trying to build a business and you really want to tie in with a product, and you can start off ties. But we're a small company, and I don't expect people to, we do enough volume to make it worth it for people. But certain manufacturers were like changing our conditions, how we work with them, over, because someone I knew who was a director there changed and moved jobs, and then suddenly that we couldn't buy direct and all these sort of things. So that time, which was really annoying, because at the time we were trying to build, we want to build around 2 manufacturers, our business. And suddenly that's changed, and we didn't have a say in it, and we found it really difficult to find technical information from manufacturers, because a lot of them are sales companies in the UK for the actual real manufacturers in the continent. So then we approached a company in Slovenia. So that's when we started doing some work with Kronoterm over in Slovenia, and kind of looked at their products and thought, wow, this is really amazing. However, is it really that good? I kind of prejudged him, if I'm completely honest. I mean, I went to Slovenia about 20 years ago on a holiday and loved it, but I just didn't think of it as engineering. I think it's got to be Austrian or German or sort of that, or even Scandinavian if it's heat pumps. But we thought, do you know what? They seem really good. We had a good response to them, had a few chats, and we thought we'll go over and see them. So we flew out to the factory and just really blown away with the product. It's amazing. I mean, really, really well designed, aesthetically, really cool products. They've designed their air source units so you can have them in different colors, cotton steel, stainless steel, black, green, whatever you want. So visually, they're really good. So for those high-end projects, they're really, really good for cascading, really good controls, can do cooling, really simple to do, control solar thermal as well as swimming pools and so on, all through one control system, and multiple zones. And just and then blown away by the quality of the build, system efficiencies, noise, and you're kind of ticking all these boxes off, and you're going, Jesus, why is this not in the UK?
Because I suppose your advantage, Dan, is you've been around a lot of makes and models, haven't you, over this sort of 15-year period, and so you kind of get a good grasp of what you're looking for.
Yeah, well, because we do aftercare, and we have to do aftercare on all products, so we won't. We feel obligated in a way, and it's sometimes to our detriment, but we feel obligated to maintain heat pump systems because not many people do. So we're F-gas certified. I've got my F-gas. I've done about as much F-gas refrigeration work as, not much at all. But we've got 2 good F-gas engineers, and our technical managers F-gas as well. And we've all done our hydrocarbons, and their skill set in terms of going out and looking after products is then the feedback. It always comes down to the controls. The heat pump's the heat pump at the end of the day, but it's all the control setups. How do they all work? What's all the nuances? From demand signal to degree days, to degree minutes, and how do they do their hot water cycling? Do they, so the old Danfoss units and Thermia units used to use operation stat, so basically take refrigeration pressure to as high as it can, just below high pressure, and then just knock off, and it will go right up. That's as hot as I can get you hot water. Some will work on a start-stop with a hysteresis, and then you'll go into the controllers, and they'll all be named slightly differently because especially on the older ones, or you'd have to press like this button, that button, put your elbow against there to get into the service menu. And you sort of learn these over the years. But anyway, so we'd seen all types, and we're very by the time we see this product, and we go, oh my God, it's really good, and it's got really good online access. So all the information you want to get, you can get to it remotely, and so. We were just like, right, well, we need to install this product. And they're like, well, we're not really looking to go into the UK at the moment. We're just come out of COVID, still struggling to get all the parts they need. I said, well, just sell us a few and we'll install them and we'll see if they're any good. So we did that. The following year, this would have been 2023. Yes, yeah, 2023. So we probably installed 5, 6, maybe 7 Kronoterm units, all really good. Customers really happy. So we progressed that into the following year, and we thought, well, we started looking at, well, maybe we could start selling this and talking to other people about it. Again, I'm not a salesperson, so and we weren't looking to grow it any fast, but just start having conversations. Are you interested in the product and so on? So then into 24, we did some interesting projects. We did a container, a 20-foot container for a welfare facility it's John Sisk. Basically, we're building 6 high-rises up in London at Wembley Park, and I met one of the project directors on a stag do, and as you do on the stag do, the first we're in the airport, I don't know, 5:30 in the morning, and you having that first pint, the only time you ever have a beer at stupid o'clock. And we're just talking shop just to kind of break the ice. And he was saying, "Oh yeah, no, I work for John Sisk. We've got this project, and we're building a 6 high-rise, but and we've got this massive welfare facility for like 2,000 people, which is going up." And I said, "Well, we do heat pumps, so I've always wanted to do like a temporary heat pump system, potentially where you can recover the waste heat and so on, and in the container, and you can move from site to site."
Yeah.
And he goes, "Oh yeah, that's a really good idea. Yeah, okay, cool." Didn't think anything more of it. We went to Dublin, had a great weekend, and that was it. And to be fair to him, 2 weeks later, because normally it's all, didn't think it was a bit of hot air maybe or something, but 2 weeks later, like he said, he emailed me and said, here's the plans for the welfare facility. What do you think? Do you want to come up with some ideas? So we said, oh yeah, okay. So we came up with this, using a 20-foot container, tunnel container, so open both sides. We'll use a couple of ground source units, put a dry air cooler on the roof, 2 thermal stores, so we can recover our waste heat, and then we'll put a preheat, another store with a coil for it, so the cold water feed will go through the coil and preheat the hot water, because we couldn't do large volumes of hot water storage. You just didn't have the space. So we thought we'll use it as a preheat, and then that can go to the point of use heaters inside the welfare facility, then to take it up to whatever temperature. So we're recovering as much heat as possible. Yeah, we'll just design it all in a container. It'll be fine. And they're like, yeah, that's a really good idea. Okay. So I work with this company called ADR Consultancy. So nowadays, really good engineer. And said, oh, do you want to help us? Do you want to do design the internals for it? And we've got to try and make it so we can reclaim as much as possible once it's taken down. So it's all like copper pipes, and we put biddle 4-pipe fan coils in, so we could do heating, cooling, all the office spaces, just radiators in the sort of so you had a big canteen and dry rooms and so on. So it's 4 stories. I mean, the load's 150 kilowatt, the heating load, and 160 kilowatt cooling load we'd get out the container, and I think the heating load was actually about 120. But anyways, it's a big office block basically, and so we designed it into this container, and we were initially going to go with Steve Weltron as heat pumps and so on. A lot of the product I'd done quite a bit of work on when they were Fermier, because they had bought out Fermier at the time, or have now. And so they'd rebadged the mega unit as a WPEI. So WPEI, that's the one. And so I knew the controller quite well, but the problem I had was, how do I defrost the dryer cooler in winter, because the ground source doesn't have a control logic to defrost. So it was like, God. So we would gone to a few dryer cooler manufacturers, and we'd gone, oh, how do you know, with your chillers, how do you, blast chillers and stuff like that, how do you defrost the coals? And he goes, oh, well, we just run an immersion electric heater through it just to melt it all. And I go, well, how long does that run for? Oh, we just run it for a couple of hours when we need to. And you're like, oh God, this is not going to work. But obviously we had this relationship with Kronoterm, so at the time we had installed a few of their units. So I rang them up and said, look, I've got this idea. What do you think? So, oh yeah, we've done something similar, not quite the same, but done some sort of similar stuff. And we've got the control logic to do defrost and so on. So yeah, that's fine. We can do that. And go, oh, okay, cool. So they built us a bespoke controller, and we worked and we, built this unit. And from I don't know November in 23, but to the following, no, between 22 when we initially had that conversation, and to 23, we had then got this container on site, fixed, connected to the welfare facility, and providing all the heating and cooling. And we wouldn't have done that. I think I would have hit a brick wall on the design element if we hadn't had someone who's so accessible, like speaking direct with the manufacturer, which was really, really cool.
And they were agile enough, it sounds like, to develop you a controller that you wanted bespoke for this particular job.
Yeah, exactly. Yeah. So I work with a project engineers, Luca, and we've actually got quite a few other projects coming up. And if we want to do anything something weird or wonderful, where the standard control system won't do it. So the problem with any heat pump system is the controls. So if we go out to an older system, it's generally like, especially commercially anyway, there's such a disconnect sometimes between the BMS and the control logic of the heating system, and then they're just fighting each other, and nothing's working at what it should, the efficiency it should be working at, or it's not doing what it should do. So yeah, if you get the controls right, and suddenly then I had access to a manufacturer who I could chat to the project engineers, and we can go, oh, can I just, what I want to do is I want to do this, and then I want, I want to use the thermal stall, and I run this to recover, to defrost, and then I'm also going to use that for the waste heat, that same circuit for the dryer cooler. Yeah, that's cool. Yeah, we can do that. Yeah. Do you want us to do this as well? And you're like, yeah, okay, that's yeah. It was suddenly then it was open.
This is quite unique, Dan, isn't it?
Yeah, exactly. It was suddenly like you had something which yes, you've got standard offerings, but if you wanted to do something really kind of more bespoke, so example, like we've got a couple of air source systems doing simultaneous heating and cooling, so we'd have two banks of air source going to the two thermal stores, and then the one air source could back up the other one, because at peak cooling load or peak heating load, you don't need the other one, so they can back up each other. But then also you could put a water source between the two thermal stores to recover waste heat. But you can do all that, and then logically, like, it makes sense. You go, there's no reason why we can't do that. But how are you going to control it? How are you going to tell when to run that heat pump, when to move that shunt valve across, when to run the water source and when not to? Because you don't want that water source coming on and then turning off after 2 minutes. You need it running and go. So it was then all that in between bits that we could suddenly, it opened up the ability that I could have an idea, I can talk to the factory, and then we can now make it happen. So suddenly, work's become a lot more fun and a lot more interesting. So anyway, the kind of that sort of process with Kronoterm was really good. We installed a load of their units and started working with a couple of other contractors who've installed a couple of their heat pumps as well now. And now we've just, beginning this year, got sole distribution rights for that product. However, one of the important things for me with Solaris was that we were an independent sort of heat pump designer, installer, and it was still really important that we provided all the aftercare to people out there who had heat pump systems.
Yeah.
And I didn't want to abandon that. I thought, well, oh my God, if Kronoterm, if it's a product I think it is, and if it really does start increasing in terms of demand, how am I going to manage those both? So we decided actually we would set up a separate company. So Solaris would still be independent, and because it was never a choice. I want to go out and distribute a product into the UK. It was kind of like, just because I like the product so much, and I actually come to the point where I go, I need to make sure it's done properly. So we've just set up the Kronoterm UK basically, and so that'll be direct with Kronoterm and us looking after it in the UK and distributing the product and providing technical support and everything else.
Is that up and running as we speak, Dan?
Uh,
Can an engineer, if they want to use that product?
at the moment, you could come to us at Solaris,
Yeah.
but I reckon probably within about 2 months, we would be set up enough that I'd be happy to start taking orders through. But we can start the process through Solaris. The thing is I really want to take it away. I want to separate it because people might think there's a conflict of interest because we're an installation company. I'm not like that, but it's you've got to be sensible as when you're setting up companies and making sure you put out the you put yourself out right what you're doing as a company, and distribution company make sure we'll give you advice and we're not going to give a competitive advantage to anybody else. But yeah, so people could come to us probably. I would say, to be honest, you can go direct to Kronoterm and contact them, and then that will come through, filter through to us anyway. Or you can contact us direct. But we're out there now doing CPDs, and I go to sort of architects and consultants, and we do a CPD on how air source heat pumps works, and then some don't need that, and some want just product. So then sometimes we go and do. It won't be a certified CPD, but we'll just go and do a presentation on Kronoterm products because they've got some really, really cool commercial units that have just come out as well, which are R290 and stuff like that. But that's sort of the circle, I guess. Quite long-winded, but that's sort of where it's funny. It's as an industry as it's starting to grow, and I definitely see it's starting to grow. It's quite a journey in terms of like technical knowledge and how you kind of built over time, and a lot of that comes.
I want to talk to you about the growth in a minute, but before I forget, you mentioned BMS there because obviously you've worked in the commercial sector, and for anyone that doesn't, or any of the listeners that don't know, that stands for Building Management Systems.
Yeah,
Which is a bit of a dark art in it, Dan. You've got whole
it
companies
is.
that are involved with that kind of industry, which is controls, isn't it? And they try and control everything. And of course, then engineers like yourself will go in with some kit that you want it controlled. You know how it should be controlled. And of course, sometimes you can end up fighting the BMS system and that whole sort of.
Yeah, if the BMS tries to do too much, they try to be too clever. Because you think about a good product, and again, I've said it earlier, but heat pumps all about controls. If you get the correct control setup, your control logic's good, and then you understand the control logic, then you can set up the heat pump for your house properly or whatever building. So if you have a BMS system which is trying to do everything, it could be doing weather compensation. So it could be looking at outdoor temperature, adjusting your flow, and mixing. It could be doing controlling pumps.
Open windows.
But yeah, it could be opening. Yeah, but if it starts trying to turn on the compressor on and off, and telling the heat pump what to do, all the R&D has been done on that heat pump to maximize performance, and it wants it. I mean, the basics of a heat pump is it likes a stable load, and because it wants to run as long as possible, and it wants a low flow temperature. So if we can manage those ourselves and go, BMS, you don't tell us what to do there. We can have some interaction, and I can take information off me, but you can't control those. Those are things we control. Then you can do whatever you like in terms of allowing zone control and allowing access, and maybe telling someone on a nice screen that I can, the unit's running or pump's running, whatever else. But when it starts, and there's some really good BMS companies out there. It sounds like I'm slating, but there's been some atrocious ones where we've gone in and looked at issues, and you've gone, oh my god, like heat pump cycling every 2 minutes, and doing this simultaneous heat and cooling, and having no thermal stores, and it's just and it was a disaster on the design, not just on the BMS but everything. And then you have to go in and sort of go, I'm really sorry, but we sort of have to start again. And that you're sort of stuck in that position, and that's the same on any kind of maintenance. It's kind of like where do you try and fight the fire and just kind of try and keep it going for him, and when do you go, no, do we need to start again here? And I find that's the hardest part, be it like a domestic system or a commercial, which is really difficult.
Going back to domestic then, so have like I say, we've established you've been in it a long time. What's the growth been like? Have you seen growth over the 15 years, and then what the last couple of years been like?
Yeah, I guess we've never had to. We were never tied into like sort of global things happening, or pandemic and stuff that affected us as a business. And we've sort of, I guess, what we've noticed is awareness. So we've had growth because we're a small company, and it doesn't take much for us to grow. So
Mm.
go from one install a month to two, three installs a month. It's not massive, but for us, it's quite a big change. You're getting more staff and so on, and then as that grows to maybe six, 7 months. But what I noticed, I'm trying to lost my thread a little bit there.
So the growth after the
Oh
pandemic.
yes, yeah. So what I noticed is uh, the awareness. Suddenly now,
Mm.
just to talk about heat pumps, like
Mm.
uh, someone asked me 15 years ago, "Oh, what are you doing?" "Oh, heating, but I'm also doing heat pumps," and they'd be like, "Oh, okay, yeah, yeah." They might ask you, "Oh, what's that?" And I mean, at the time, I'd probably try and explain it not very well, but um,
Most of the time, they don't even ask what's
yeah,
that.
yeah. But as now, actually, people really, my wife gets really annoyed because, and I honestly don't try and do it. But say if I go out and meet, we're, I don't know, chatting, I don't know, we go to a party or something with the kids, and you're chatting to one of the dads, and you go, "Oh, what do you do?" And they go, "Oh, in heat pumps." "Oh, yeah, no, I've heard about those." And suddenly you're into a conversation probably for 20 minutes about heat pumps. And then my wife comes over and goes, "Are you talking bloody heat pumps again?" And I said, "I didn't. It wasn't. It wasn't my fault." Whereas, and that's a much more, uh, and that's kind of how I think society, like, you've seen a new advert now. I saw it the first time the other day on the TV. Was is it Desnes now? I've got to forget, keep
Hmm.
up with the Department of Energy Security Net Zero, I think that's it, isn't it?
Hmm.
They had their advert on about heat pump awareness and stuff. And I thought, oh, I mean, never would have seen that. I thought we'd see that, 5, 10 years ago.
Mm.
Um, so I think in terms of people are building houses now, they're doing any renovation work, or if you're building a new build, you're putting a heat pump in. However, I don't. It was difficult enough 15 years ago to start trying to find information about heat pumps. However, now there's so much information, but how do you digest it? Because it's like a vomit.
Yeah.
It's been vomited out. There's no. It hasn't been. There's no sort of. The industry is so. It's still fragmented. It's too fragmented. I think it's getting a lot better. There's some really good people out there who are trying to start.
There is kind of an information overload, actually, isn't it?
It is, isn't it? And it is, and it should, and it's people are making it overly complicated.
Mm.
More than they need to. Um, at the end of the day, it's a heating system which is your medium's water. You know, you heat up the water. You want that energy now to be rejected into your space inside your home to heat it up. There's no difference to your boiler. There's some design parameter differences, flow rates and so on. So then your pipe size is different, but it's still the same. And it's there's not a massive. Um, I just think the problem was, so we've go back to boilers. Is the combination boiler came out, and honestly, I think a lot of the skill sets started going. So when I first did my apprenticeship 20 years ago, the old boy I worked with, he was doing heat loss calculations,
Mm.
and he would do pipe size, and he would have his
Mears calculator.
Mears calculator. Thank you. Yeah, yeah. And
Mine's about a
he
metre
I
to the
think
left of me.
nice. So he would he would, I think his apprenticeship when he was young was about 5, 6 years. Um, and at the time when I did mine, it was 2 years, whatever it was. And I didn't even do my level 3 actually because it was just so mind-numbingly boring. I found it. It just wasn't. Uh,
Not suited to you.
no, not suited for me. I've always been a self-learner. I like doing things myself on my own time. I'm not so. That's why I wasn't great at school, I guess.
Interesting. I mean, like you said, the person you first worked with, who you did your apprenticeship with, sort of old school, Mears calculator, sort of calculating stuff like that. I suppose because if you go back that kind of to that generation, similar to some of the people I was working with when I was doing my apprenticeship, is they were working in homes that were still transitioning to heating systems. So a lot of
Yeah,
these homes, so for instance, the home I grew up in didn't have a central heating system till 1981. So you still had, there was this slow transition, wasn't there, going especially through the 70s. People was, I grew up in a home where my brothers and I, we all got dressed in the morning in front of a coal fire that Dad lit. And yeah, you flannel washed all through the week and only had a bath at the end of the football match for your Saturday. So yeah, there was a bit of that calculation going on, and like you say, we transitioned quite quickly after that, then into things like the combi boiler. Um, I don't want to, I don't know.
but you had gravity in like one pipe system. I mean, commissioning that
Oh
is
yeah, we
it's
went.
not.
Yeah, gravity.
Those sort of things. Those are systems where you had to think about what you were
Yeah,
doing. You couldn't just put
semi-gravity
a
systems and fully pumped. We
yeah.
moved to fully pumped, didn't we, in the
Then you
80s?
yes, exactly, yeah, and then so it's only all those systems where so pipe sizing was important then, and you had to work it out, and you had to install it correctly. You had to really think about what you're doing, and for some reason it became this de-skilled job or perception that it was these and and uh, and then suddenly people were becoming plumbers who 2 days ago was a postman
Yeah.
and there's so much more to it that I feel like I've only still scratched the surface and I really try and that's why I set up a company doing purely heat pumps because I thought, do you know what, it's too big to do everything. If I want to really know about one subject, I have to try and focus in because otherwise, you start talking about MVHR or different other renewable systems from wind turbines and PV. You start going, it's so big. How are you supposed to be specialist if you're doing all of those? You can't.
Mm.
It's not feasible. And then we go into those kind of combination boilers, push fit, and then it's like it became more and more de-skilled. And so I feel like we're just kind of finding out the shortcomings of where we relied so much on the easy. One of the manufacturers came in and said, "We've got a solution for everybody. We've made it really easy. Anybody can do it now."
Mm-hmm.
And suddenly now we've got a massive shortfall of skilled workers.
Mm.
Um, and it's like pipe fitters. It's like pipe fitters are amazing. You get a really good pipe fitter. Um, he will do a much better job than I will do installing a system. I might I'll have in my head, but I will still talk to. I've got a couple of guys that I will talk to them about. Oh, yeah, how would you do this section here? Because we do 3D modeling, so
Mm-hmm.
of like if we're doing commercial systems, generally find it's best to model it because you don't want to get a fitting wrong because it costs you quite a lot of money if you miss something out or something like that. And I will talk to them about how we set it up or how how you do that, and that's a skill set. He's done that for like 20 years, 30 years. I mean, uh, you can't you have to physically be doing those jobs for that long and it's so skilled.
Very skilled. They're like artists. I mean, Paul Hull is one of my favourites. You put him in a plant room with his 48 Stilsons and away he goes.
Yeah, so so I do quite a bit with Chris Flaherty.
Yeah, Chris. Yeah, 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 yeah.
So I mean Chris had done so I started doing some work. It was
Chris would have got
actually
you into the VDI 2035 stuff then.
yeah, that's exactly where I got into it. Yeah, through
Mm.
Chris. So I met Chris on a just when I started up Solaris. I we were on a job together. I was doing the plant room, so when I first started, it was just me. Did everything. So I was doing the plant room installation. He was doing the mechanical installation inside the house, and we just started chatting shop. And it's just like plumbing chat, proper into like see you using this because I was using Vega, he was using Gebrit, and we were going I like that system, and we're talking, and at the time I was fitting it was a ground open loop system a Thermia ground source with passive cooling, just a little plant room, nothing too big. But we just started chatting shop, and then we've done quite a few decent like size projects together. Where he's come and done like the installation part with us. Um, yeah, really good guy. Got a lot of time for Chris.
I want to dive a bit into the controls a bit more in a minute. I don't know if you got a chance to listen to this. I think it was the last episode I've just released, the one with Ken Bone. We discussed controls. and like yourself, Ken's been around heat pumps for a long time. And we were discussing the issues with controls with manufacturers. But I want to just before that and remind me because I probably forget. MCS, so like you mentioned earlier, you've been part of their working group. So MCS has got an installer working group, and I think Leah's on it, and I think Emma's on it, Emma Bowen, and I think
Yeah,
Barry Sharp's on it as well as he, and obviously
that's
you're
it.
on it.
Yeah.
And so, just for the listeners, sort of, you've had sort of a really sort of granular bird's eye view of MCS and sort of the things and the changes over time. So, what's been going on there? What's coming? Or, you know, do you think anything else needs to be done from the installer's perspective or the customer's perspective?
Yeah. So if I take it back a little bit further, so just before MCS became a charitable foundation, I found the whole MCS thing. It was purely there just for government subsidies, and but they had written they had written a good standard really for design element and had some good elements. It just had a terrible. It was set up for those big companies, and so when it went into the charitable foundation, and it was burdened with this QMS system, quality management system that, like, when I started my company on my own, I suddenly had to have meetings with myself. It was it was ridiculous. And so it wasn't, and all the best installer, and a lot of the companies growing, they're not big, they're not British Gas or Aero or Octopus, those, and so it was kind of burdened with this, and so they started stuff. The installer work group. I can't remember, a couple of years ago. Can't remember what it was, to be honest. Everything sort of merged into one, and it kind of gave us an opportunity to kind of voice like our concerns, and I feel like they've taken a lot of that, and they've had to make they've made some real big changes, which I think a lesser person. So I can't remember his name off the top of my head now for some reason. Ian Rippon.
Ian Rippon, yeah.
So Ian, I think fair play to him. He took our feedback, and he's gone back, and MCS as a whole, God, we need to radically change it. And I think the changes they've made, and it's taken a lot longer. I thought it would be done 2 years ago, but there's a world which, I'm in my little plumbing world or heat pump world, and there's so many other elements outside that which you just don't see until you start in these working groups and you see the kind of the obstacles they come up against, and it's so hard to change certain things, especially when it's kind of ingrained or it's gone through legislation or whatever else it might be. So I feel the change now, it's got the best intentions to allow installers to come into the industry and potentially start installing heat pumps. And I mean, like, Emma and Leah and Paul Lee and Barry and so on. I feel everybody wants to kind of help, and no one's going, oh, I want to make it so I can make loads of money. So no, we just want people doing it right. We want people to look at the industry and say we're all working together here. We want the government to look at heat pump industry and go, oh, actually, these guys here, they're really doing something great here, and I can see how there's an industry here which the UK could thrive from. And I mean, don't want to jump off context too much, but it's like the biggest thing holding us back is the spark gap. That is, and I still don't understand that. I still can't understand how electricity is so expensive compared to gas.
And that's from your customer's perspective. So you're not getting the customers, you think, because that's one of the biggest things.
No. Well, I think the industry as a whole, because in terms of, you just look at a heat pump compared to a fossil fuel in terms of how much energy it consumes, it's significantly lower. I mean, ridiculously lower. And even if it doesn't work that well, it's still much lower. But money talks, and it's the economics of it. And people just want to heat their home, but they don't want it to be really expensive. And if they can sort that, that's going to be the biggest impact for the industry as a whole.
Do you think that would
I
help
mean,
if so if customers realise there is a super low price system to run? Do you think that's going to help people? Because obviously the outlay for a lot of people is still quite expensive. If we did sort of narrow this, what people call the spark gap, and we got really low running costs, would that be enough to push a lot more people over the edge to sort of get
yeah,
this?
because you can suddenly right. So right, I mean, this is off the top of the head, so might sound ridiculous, but here we go. So if you've got lower running costs, then suddenly you've compared it, say someone that was on gas and they're paying £2,000 a year, they run the heat system, but suddenly then you can half their bill, and suddenly now you can go right. Well, with government help, you can maybe do interest-free loans or loans, which then there can be loads of different mechanisms now, which can which the banks, and that's what they should be doing, is helping out people because they've all got targets to reduce their carbon emissions. So suddenly now there's enough money in it for then the banks or whoever else to go right. Well, we can show that we're reducing carbon by getting heat pumps installed into people who who are in fuel poverty and so on. I mean, there's loads of opportunities now to open up another sector. This is a sector I don't know anything about, but there's opportunities then that can happen if you reduce that spark gap. So in terms of, I think the setup, like with MCS and installers now, I think there's opportunities to get on, but the stopping gap, I think, for everything is that if that changes suddenly, it's like everything gets a little bit supercharged. The people who hold the purses will suddenly now put a bit more money in, and I don't understand why it is, because my understanding and from speaking to people is the reason it's so expensive is because it's tracked through the gas price, so the wholesale price to the energy suppliers. It's the base rate of electricity is based on the most expensive fuel type into the network. So, example, if you've got wind power and PV and hydroelectric, or even if you're importing electricity and it's cheap, it's 10 pence a kilowatt hour, I don't know, whatever. And so it can be sold at 10 pence a kilowatt hour. But it's based on the most expensive. So the problem is because gas is so expensive and it makes up a mix of our fuel type, that now is the price. Regardless of all this, they will have to sell their electricity at this price. So it's artificially inflated. And I'm surely that I can't understand why, only politically, is why I can't see it happened, why that hasn't come down.
It's complex. I mean, I've got a sourcing off gem, and it's not an area I quite understand. But I know.
No, it's me too. I know. When you
I
hear a
know a
little
lot
bit
of.
and you go, oh.
I know a lot of people in policy that have explained it to me. I mean, and obviously we've got lots of people asking for this, to narrow that DT, is it delta price,
Yeah.
and yeah, and obviously lots of reports have been written about it. It's the main thing everyone will talk about, and there'll be lots more reports, I'm sure, in the future to say exactly the same thing. Government are aware of it, and everyone is aware of it. The mechanisms for how it changes, I'm not too sure of. I've been told it's difficult. I mean, but that's about as far as I know.
But the thing is, right? Government's there for the people, right? That's mainly its objective, to allow people to thrive. I guess that's probably the best way. So the biggest problem for everybody. So, example, the steel works at the moment. Looking at close. Reason why it's struggling is because it's too expensive to run because energy prices are too high. And whose fault's that? I mean, again, it's government. And so why can't they sort it? If it's just it's difficult, well then everybody has difficult parts of their job. You have to come up with a solution. That's what engineering is. It's an equation. It's going how do you
That's a
how do you
utopian government we're talking about.
yeah, I know. I know. That's the thing is when you see it from an outset, I guess you can you get frustrated, and I can't understand why. I need someone to tell me. I guess maybe if you could get someone on to explain it, that would be helpful.
Well, diving back into something you do know something about,
Yeah, okay, yeah.
controls. So, the what would you say is our bet? So, if you were to buy some of the units you have been buying,
Mhm.
and you, as we've discussed, you've used quite a few manufacturers over the years. The controls on the so there's been lots of conversations about controls. I get lots of people ask me questions about controls.
Yeah,
The department, the energy department, have been chatting about controls and manufacturers and controls. What you've mentioned there is quite interesting. What you mentioned earlier about how you managed to get an actual manufacturer to make bespoke controls for what you particularly needed very, very
mhm.
quickly. Now that's quite unheard of with some of these massive super entities that are in this industry. I mean, some of them are huge entities, across the
Yeah,
world. People like your Dakins, LG. Um, what is it for the layperson? Because obviously controls is complex. It's complex for engineers. It's complex for definitely homeowners, and ideally they don't want to be touching anything that just runs automatically. But what are the sort of the differences? What differentiates the controls that you've come across with the Kronoterm, and what can it do? Or what people can people expect it to do?
yeah. Well, controls, just as a generic sort of thing, it's controls is only good as it's been commissioned. Um,
Yeah.
so whoever's designed it would have put a control system in, and and it could be because it's a customer requirement, and we can't ignore that. So the customer wanted it, and you can give them all the options, but if that's what they want, that's what they want. Uh, so then, as a commission engineer, you need to make sure you set that up for the customer, but potentially the most efficient system. Going back to fossil fuel, you don't really get this. You're not impacting the efficiency of the unit. Say, for example, if you're cycling, you're changing load all the time. Um, modulating burners, they can modulate down quite a lot. It's definitely not working as efficient, but you get what I'm saying. However, as soon as you have a control system, if it's designed poorly, even if you commission it well, it's potentially going to impact the efficiency of the heat pump, and it's more likely to. So I guess you could just put it in like a risk assessment. How do you get your control system in? So it's designed in a way you're going to have the least amount of problems. So that's why I generally like to have minimal amount of control, because you've already got a really good control system in the heat pump with weather compensation. So why when we were talking about conflicting with BMS was the same with a boiler interlock and Part L and programmable stats, that if you've got a control that's inside the building, if that's now cycling the heat pump, that's no good. So then we want this least amount of information being dialed in. So my preference is always I like a manufacturer's controller. You still can zone if you want, but then that's in, so you put adaptive heat control. So you've got another data point into your control logic. So external temperature, internal temperature, and then your heat curve. So then it's got another data point, so it can refine it and maximize system efficiency and keep comfort. So if they want it hotter, it will automatically up the heat curve if they've suddenly now want it 2 degrees hotter than what they previously wanted it. But it's not going to impact system efficiency. It's actually, you're still going to get the comfort and get your efficiency. So when you start putting more and more layers in, then you're mitigating that risk by putting buffer stores in to do that. And that buffer store gets bigger, the more you want to, or you've got inverter driven. So obviously when inverter driven heat pumps, because inverter starting is a lot more fixed speed. So inverter driven heat pumps, and then so that can modulate load, but obviously you still have cycling issues. So I don't think you can have any control system. I think they all work. I find some of them, the way they're marketed, it's ridiculous. It's like with all the online access, all we really want to be able to do is just turn it up and down. Or, say, for example, if you've got multiple stats, you do want to be able to change it on your phone. You want to be able to change temperature. Everything else above than that, you don't really need. You want it nice and simple. You just want to be able to change temperature because that's your comfort level, and that's all you want it for. The only time it becomes a little bit more complex if you introduce cooling. So if you do like light cooling through your underfloor heating, and so some heat pumps, say, for example, the Kronoterm unit's really good because it's easy to activate cooling. You can do it automatically. We generally tend to do it on the app. So you go, I'm into summer now, I want cooling activate. Unit will now go into still do hot water production, but now it'll produce chilled water. Now you can select if you know you've got underfloor heating. If you've got third-party controls, well, how are you going to activate cooling now in all those different rooms? Because it doesn't have a cooling option in it. So then if you use manufacturer's controls, it's much easier to do. And then if all those living spaces are all the same design temperature, why do you need a thermostat in each of them? You just need a control stat. You can't have your master stat to say, this is my base temperature for the whole of it. Because if it's overheating in the room, in certain rooms, it's generally going to be maybe because it hasn't been set up or balanced correctly, potentially, or there's quite a few different things it could be. But
Why do you think, Dan, back in the day, a lot of heat pump systems, despite the fact, the actual heat pump had its own controls, got put in with third-party controls because it seemed to be a bit of a thing.
Well, I did it because that's what you did.
Is that but who was pushing that? Was it the third-party control industry pushing that?
No, so it was Part L, wasn't it? So you had Part L came in. So I remember on a couple of jobs before it started Solaris, you had build control, and it doesn't matter what.
This is where I think it all went a bit wrong because Part L. I mean, there's 3 words in Part L: use effective control. That's it. That's the law. That's the requirement. Everything else around them 3 words is guidance to meet the requirement. And people are now starting to realise that. But the manufacturers back in the day, once they were in that approved document, they kind of were telling, or I don't know if they were doing it on purpose, but people just thinking, right, it's now law, it's now requirement to have TRVs everywhere, right.
Yeah.
Well, it wasn't. The actual requirement is just 3 words: use effective control.
Yeah.
And we're all now living in a world where we realise, well, actually, that wasn't actually effective control. The way we're controlling boilers isn't actually effective, and
well, I think it was effective enough with boilers because the whole point with boilers is they were running when they shouldn't have been, and it was turning them off. So the least, you're going to use the least amount of energy if you're not running. Yes, you might not be running efficiently, but at least you're not running.
Yeah, but I mean, with the things like the TRVs, so I mean, you used to get people say to me, TRVs are a legal requirement. Well, they're not. It's not at all, and nor is this whole thing of zoning. It's still part of guidance that you can use, and the approved document actually explicitly states, even if you use the guidance, doesn't mean you've met the requirement. It sort of caveats that. But yeah, I suppose you're right. So I suppose that whole thing of Part L, because as you and I know, when we were doing our apprenticeships, very, very, very few people were aware of, or they weren't reading building regulations or approved documents. The people we were working with, but when Part L came around, there was a bit of a fanfare around it. All the colleges were talking about it. It had to be taught in the City and Guilds level 2 and level 3. The conservation of fuel and power. It became a big thing. And so people really did start to talk about it. And I suppose, the third-party controls manufacturers run with that because obviously that was a big thing to their industry, isn't it? They're putting stats here, there, and everywhere. Every room they'd like you to have them.
Well, and also you think about the amount of cost that put on. You think if you follow, you go and people obsessed with it. They want a stat in every room, and you're like, oh my god, the additional cost you're putting on. Let alone this is not good for the system. So these are sort of things, and it's not the heat pump industry is having to break this cycle, and the thing is, people, if you're having to then explain yourself all the time. Well, my friend told me you need to have all these, and you're like, okay, well, get him to do it, But but those are the sort of things it's not just the heat pump. It's because the heat pump, and quite rightly, and this is what happened with the boilers, is it became the center of everything. Everything was just around that boiler, and people are kind of expecting that with heat pumps. Well, the heat pump should do everything. No. Heat pump is part of the design. It's like the engine of the car. You've still got all the other components that you've got to sort out, and you've still got to distribute your heat. You've still got to size everything correctly, and every system's bespoke. It's and it takes time, energy, and effort, and the customer has to be on board. The customer has to understand. And I'm not getting me wrong, you get some really good customers who get it and who are like, they want to spend the time, they want to listen to you, and they understand it, and some don't. So then you find yourself when you get to certain jobs and you go, oh, I don't want to do that, but this is what they really want, and then how do I push against it without forcing them into a position? Because you never force a customer to do something because you're just going to end up down a road you don't want to go down. And I've been down that road. It's not fun, even if you had the best intentions. So it's not, this is the thing, and controls is massively like, so people getting over now. I think the radiators and the oversized, and actually the oversized isn't actually that big, and it's not massively, it's not horrendous, and I think people are kind of getting their head around that. But controls are still the one where people are still unsure what's the best, and there's so many different ways to do it. That's the thing as well. There's which option do you choose in every job, which fits? Because I don't think there's, and the more options you have, then it's harder then to, say, for example, with my team, to make sure in what scenario do you use which type of control logic or control setup, and which scenario do you use manufacturer control, and which scenario. So then, if you're building a business, you need to try and offload as much of your own work as possible. So you need to, processes, and so then you're like, well, do I standardize? But if I standardize, then I'm not engineering. I'm making sure I'm answering all the questions. So you're really finding. So we do a lot of design work. We've got two design engineers. One that I'm putting through is he's a mechanical engineer, and the other one is going through with him through his Open University doing his engineering. And they're great young lads, and they do all the CAD, and they do all our designs, and we do a bit of consultancy work for other people and try and. But that's where drawings come into effect. So that's how we kind of get over all the control issues, by doing as much drawing as possible. Because if you suddenly do something a little bit bespoke, and it might just be putting a relay in, say, for example, bit of passive cooling on the ground source, or if you're doing light cooling for an air source, and you want to use the underfloor heating, but you don't want to put you don't want to put expensive third party controls in, like real bespoke. You want to use maybe like heat misers. Well, how do you then go into cooling? They do like a heat and cooling one, but for fan coils. Well, the other option is you can't use manufacturers for whatever reason. Then you could just put in some relays on the demand signal when it goes to cooling, just open up the actuators and then let the sort of cooling heat curve control it, and just take away that overheating in the building. But how do you coordinate that?
Because you've got your own CAD draw. Because obviously some people now are using off-the-shelf software, aren't they, for their design and drawing?
Yeah, we do everything CAD.
You've got your own CAD designers, haven't you?
Yeah. So that's my thing. I love like the control, the logic. I love anything where you can go from A to B. So it's either putting a spreadsheet together or drawing up CAD drawings, based on whatever you want to be installed, and then commission it as well. So we're trying to think, how do we do the drawing so to make sure you've got all the information when you go to commission it? You go, well, I know how I need to set this up and what I should be expecting, what I should be setting up on the heat pump, what I should be setting up on the controls, what flow rate should I be getting, again, going back to water quality. And these are all testable. That's the nice thing about, say, chemical free. There's actually now a way to test the water quality. So then you can put that into your commissioning. You go, I know the pH, I know the electroconductivity. So those are things you can now start recording. But these aren't normal things happening in the industry. I think more and more people are doing it, and I feel probably stuff from like your podcast and stuff are really starting to get that word out. So people are taking it more seriously, and I think people who really engage in it really enjoy their job more.
I think there's a big reawakening of there's a lot of engineers out there that are really loving the fact that science has been brought back into their industry, and also that there are customers out there that appreciate that they know the science and the engineering aspect of it.
Yeah, exactly.
And there's also some great customers out there. Before I forget, air to air, you guys have got your F gases and all this sort of stuff. Are you finding that domestic people are asking for air to air at all yet, or do you sort of offer it as a service?
We do it, but we don't like promote it. So, for example, if we're doing the installation and someone wants cooling just in one bedroom, and they don't just want a bit light cooling, they want like comfort cooling, and we go, well, it makes sense just to put an air to air into that room if you want that level. That's the most cost effective way of doing it. So we might do it then, or if it's something we know we'll potentially do it. But we generally try not to the reason why we've got ref gas is mainly for the maintenance
Makes sense.
side. So compressor changes and repairing leaks and
Which brings me
expansion valves.
to it's a nice segue. It's American podcasters ways they love that word, don't they? To breakdowns. So obviously you guys are kitted up very well to be able to do breakdowns, and as we're seeing a growth in this sort of installation side of this. But a lot of the installers who do some great stuff haven't probably got the tacit knowledge of some of the stuff that's already out there, and haven't got their F gas, and probably aren't quite ready to do breakdowns it, because that does involve actually some that's kind of a thing that you don't learn. It's experience, isn't it, in some ways?
Yeah,
And
yeah,
what are you sort of finding out there? Is there anything? Is there a time period where certain things are breaking down? Maybe manufacturer specific, or certain components that are breaking down after a sort of time. What as a breakdown company that what are the sort of things you're seeing regarding that?
yeah. Yeah, that's a really good point. So we one of the reasons we went over to chemical free was because majority of failures on heat systems, on heat pumps, was down to mechanical parts, pumps, valves failing, and so on, or
Because of the
heat
water
exchangers
quality.
blocking up because of water quality,
Mm,
corrosion.
mm.
And I mean, majority of them, probably 80% of them, is all down to water quality. And it was so hard to try and manage it. Um, and to be honest, until I started looking at water quality a bit more, I mean, I was completely naive to the water quality. You put a bit of inhibitor in, you go, oh, is that enough? Probably. Magna Clean's clear. Oh, that's picking up the debris, so at least it's not getting into the heat exchanger. But yeah, water quality is definitely the thing we get the most problems from. It's like when we go out to a system, it's not our own, and we go and look at it and we go, yeah, water quality is bad here. There might be some other bits, but how far have components worn down? And then it's just a ticking time bomb until component failures. Whereas if you get the water quality right, and stuff like air ingress, you can get the water quality right, but if you don't get oxygen in, then you're fine. But if you've got any air ingress, so stuff like your expansion vessels, really important, people probably weren't taken into account and looking after system pressure and closing auto air vents, and once you've filled and commissioned, just close them off. Those oxygen is the killer. It's in any heating system. So if we keep that out. Otherwise, when it comes to the components, the heat pump itself, unless it's been set up, so you might get failures because potentially the heat pump's been set up and it's cycling. It's been turning on and off, or it's been running really hot. So obviously on the compressor, you don't want that suction gas coming back in, and you want that flash gas coming off it and stuff like that. So you don't want that compressor getting really hot. So you're more likely to get a failure down on your compressor. Occasionally we get like compressor might stall and come off its windings or something like that. But generally, or expansion valve might not be working quite right, or
Anything major like the heat exchanger, condenser heat exchanger?
but the condenser, generally the reason it's failed is we've had pinhole leaks on the fridge
Mm.
side into the condenser, which is a bit of a nightmare to find sometimes. And that's again down to water quality,
Mm.
debris down to water quality in the system.
Because as you all know, there's a bit of a fear, and there's a sort of a bit of a new industry that's emerged sort of recently, I suppose, relatively speaking. It is these antifreeze valves. So if we go back in the day, some people did put glycol in the systems, obviously, especially if they're up in the Outer Hebrides or something. But people
Yeah,
in colder countries than ours didn't have antifreeze valves. They've become a bit of a thing. You were around before they were a bit of a thing. I mean,
yeah,
what's your sort of opinion on all that kind of stuff?
yeah. So I did, I did the whole, filling up with glycol and purging the system up, and a couple of little things. If you hadn't mixed the glycol quite correctly, so we've got guys and got commissioning, and you'd only the bottom of the radiator would warm up because they hadn't mixed the glycol and water, because the glycol would just fly across from the bottom and then the top part, and for some reason it just wouldn't heat the whole radiator, so you'd have to get it turbulent in there to get it mixed and get it working anyway. But yeah, so glycol again, it's fine if if you design it that way and you maintain it and you look after it and you look after the pH and so on, then but it's expensive. Glycol's, I mean, now it's so expensive. If you trying to and also when you go to that chemical free approach, when you think about it and increasing electroconductivity by having all the minerals and salts, you just go, oh, just this is a risk. I don't this is a risk come back on me because I've designed it or I've put that in the system. This again come back to product knowledge. So the Cleffy valve coming out, the antifreeze valve, the Cleffy one obviously came out first. Yeah, it was great. It was like, oh, great, we can comply with what the manufacturer wants. And a couple of manufacturers obviously don't require even an antifreeze valve. They're happy with their own logic. So I know, I'm pretty sure Nibi and Stiebel were like, no, we don't need to have that. But the others said, oh, put this valve in. And actually, they've been pretty good. But we're at the point now where
Have you had any issues? Have you? Because obviously you're going to breakdown. Have you had any issues?
Not loads. No, not. I wouldn't say. I mean, obviously, I'm not going to many breakdowns these days. But in terms of, I sit with my technical manager and we go through what components are failing because we're trying to work out, like, how we can mitigate when we go out and look at a job and say, like, this is more like most likely going to fail and what we should be using on our own system. And that's the great thing about doing breakdowns, the best learning curve. And because it's my background as well. But yeah, I haven't found them failing massively. No. I've seen them installed poorly or not, pipework not insulated properly and all those sort of things. But no, I don't. But I do question sometimes if you really need it. And so we did install on quite a few systems, and we do install because some manufacturers state they need X and Y. So, for example, we only fit one on the return because my logic is that it's basically there to stop that condenser freezing, the water freezing that condenser and causing a failure on that condenser. So if you've got one valve on there, yes, potentially you might say, oh, you're not going to have an air intake and it's not now the water's not going to drain out. But actually, I just want that to open because if it starts freezing, you're going to get it's just going to go least resistance, path of least resistance. It's going to be easier to go out that hole than it is to freeze in the heat exchanger, and that's my logic. Now, someone probably can say if that's wrong or right. And then we do get service engineers coming out and going, oh, it's only got one on it. That's not manufacturer's instructions. And you go, well, if it freezes the condenser, I'll take it on the chin then, because I can't see the point. But I do look in certain scenarios and go, is it 100% needed? And I don't think it's. I think with all products, I don't think they always need. Like people go, oh, I need to fit on everyone. No, use a bit of
engineering sense.
Yeah, exactly.
What about the
Be confident enough to make that decision? Yeah.
What about the manufacturer? You're working very closely with Kronoterm. What's their viewpoint?
Yeah, so I had a really good talk to them about it, and so they've got a couple of climate chambers, and what they did a test to see how long it would take for the water in the pipe in the heat pump to freeze. So this isn't in the heat exchanger. This is on a bit of exposed pipe, uninsulated, and it took. So it's at -10, and it took 12 hours until the water started to freeze. So that's not it frozen. It's now phase changing. So it's turning to ice. So so if you're in a position where it's going to be -10 for over 12 hours with no power, because if you've got power, control logic is if it goes below a certain temperature on the sensor, it will run the pump. So you've got flow, you're using the temperature of the building. Generally, you're running your heating. So so as long as you've got circulation, you're not going to freeze. But it means you've got a 12-hour window. So yes, if it was -10 for more than 12 hours, there is this potential then that could freeze. And that's then if it's not insulated properly. So then, well, make the choice. I like to think, well, there's certain places that it will never be. Yeah, if it's out in the sticks, and I go, they do suffer from power cuts, and it's exposed, and they have a massive wind chill, and it is quite cold because it's high up. Then maybe you go, oh, I need to consider this at least. But to put it on every job, I think people And I guess that's the difference between the design element and the installation. Installer, oh, I don't want that liability. Whereas you have a designer to go, do you know what? I've considered this and I've got enough information that I'm happy in this scenario. You don't need to fit it. I
Mm.
guess maybe that's the difference. And
Mm.
we've got enough experience to make that decision. So I wouldn't want to. We do a design service, I guess. So we could make that decision for other people, I guess. But and there you go.
I suppose the last thing um, I probably want to talk about is, have you got any views on training? So obviously you're in the
Yeah.
installer working group. I mean, is that a topic that gets discussed, training, or have you got?
Yeah, I'm in the. I've been part of the low carbon heating technician apprenticeship.
Yeah.
Only a small part. I can't put my two pennies worth in. Training I find quite difficult because it's a completely different world to me, the whole training setup. However, I know how I want to install the heat pump. I know what information I want to give to our guys, and that we train in house really, because a lot of our training is actually done in more in house. We do a lot of sort of short courses, which we find are really helpful. But no, training for me that's the number one, isn't it? It's how do we get the right information to the right people, and then how do you stage it? I would like to see like a modular sort of system, really modular, because it's so many multi skill sets in heat pumps, isn't it? From refrigeration, electrical, mechanical, um, and commissioning, installation, and you don't you don't need people who can do all of it. And so why do we want to have a system which is trying to get them to do all of it and go designer? You want kind of what people to be able to go to modular so they can build it up and they and go, oh, actually, I really enjoy the electrical side of it. And actually, I'm going to go into a bit more PV and I can do the wiring and I get the controls and heat pumps, but I'm going to go and do PV and batteries. And I like the integration and controls. And you have someone who goes, I like installing and I want to go pipe fitting. I want to do bigger commercial systems. And you're going to get someone who goes, I like aftercare. So I might go into the refrigeration side because I want to be able to repair and I need to understand electrical, but I don't need to be, and I need to understand controls, but I don't need to know, I guess, as much about integration. I need to, but there might be a module which bolts in nicely, it works with it. So if you could get a good modular system, which then as an employer, I can look and go, oh, I can see you've got these modules. That's perfect, exactly what we're looking for. Do you know what I mean? I suddenly then can, which are competent. I know they're competent, as competent as you can be, I guess, with any training. But that would be like the ideal
Mm.
scenario. But then I mean, I thought the heat pump industry was a bit of a mess. The training one just seems just like a that's another, which is something which I just I don't understand because a lot of it's all about funding and so on. So yeah, I find it must be really difficult to.
It's like another universe.
Yes, yes,
It's
but
like,
it's weird. Do you know what I mean? We go, I'd like to help, but I don't really know how I can help. You know?
well, Dan, it's been a pleasure having a chat with you today. Really appreciate you coming on
No
and
problem.
discussing your journey. And I think sort of a lot of listeners will find it valuable because your journey's been sort of quite long, a lot longer than sort of the most, if we think about some of the people we chat to now, etc., etc. So, yeah, really appreciate your time. Thank you very much for coming on.
Sure. No problem.